In 2005, the Huygens Probe landed on Titan, and with the DISR instrument, it took one image of the surface. A very narrow field of view, a very small definition image, because the probe was made in the 90s. And so from this single image, we could not do really a movie, and we couldn't imagine an entire scene. Although in this image we see some pebbles, we see that the probe landed in a lake bed, dry lake bed, but with some detail. But we needed more information than this picture could offer. So we recreated, based on the scientific data acquired by the probe, some spectrum, polarization, and some images as well, to have information about how the light is scattered in different directions. These new images that represent what a human would see if standing on Titan, but with a larger field of view. So we have actually a virtual reality experiment with a 360 degrees view of a probable surface that a human would see on Titan. We talked with the mission scientists who designed the instrument that went on Titan with the Huygens Probe, and we got this data, and we integrated them into our ray tracing 3D model. So there is the sky model for the illumination of the scene, there is the surface model for the reflection of this light on the surface and the scattering of this light, and which also gives us the color of the surface. And finally, there is the atmosphere of Titan that has a very thick haze, but on the surface layer it's quite thin, and we have a good visibility, actually, contrary to what we could think. And this haze layer allowed us to see how the lights from the distant mountains and the lake beds rims are attenuated and lose their contrast because of this haze layer and the atmosphere in general. Working with the scientists was really great, and talking to the people who landed the probe on Titan, it was fantastic. And getting their data was a bit of a challenge for us, because we usually work with the data that we measure on our own with our hardware. There we were taking just tables of numbers, very big tables, for different wavelengths, for different altitudes, for different azimuths and so on. And we had to recreate this virtual world from all this data, and it was a bit hard to talk with them, because they use very accurate scientific information with precise units, and we also do, but with different units. So we had to convert data, make sure we speak the same language on every data that we had, and we had a lot of data. So it was a really great experience. And also, yeah, we saw that the haze is not that thick near the surface of Titan, contrary to what we could think, because we cannot see the surface from space or from Earth. So we could, before this mission, we thought that the haze is present everywhere, and near the surface we cannot see like more than 100 meters or a few yards, but we actually have a very good visibility near the surface. It's more in the altitude at 40 miles that we have a very thick layer. But it's really great to see these images, and we can also see the sun through this thick atmosphere. Reaching the surface, we see a very small, it's like a tenth of the size of the sun on Earth. So it's a very small spot, but very still bright spot through this atmosphere. We weren't really sure, I mean, as the public, not as a scientist, we were not really sure if we could actually see the sun directly through this atmosphere. And we can, because the simulation showed that it's still a number of times brighter than the average light brightness of the sky.